Okay, let's continue it. So what we've done is we've actually found the function that will tell us the slope of the surfboard at any point on the function y equals x squared. So the question, let's try this for other functions. And another thing we've noticed, you might have noticed, is that we had x squared raised to the second power, and the derivative went down to 2x. Once again, that's from the last class, not a coincidence. I'm going to erase this, take a screenshot if you need the notes. So let's continue, let's try another one. How about we do the derivative of x cubed? So y equals x cubed. We know the graph looks something like this. And I want to know how to find the slope of all the tangents anywhere here. Here, 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 here. I want to know how to find the slopes anywhere. Right? So I use the formula. I say the limit as h goes to 0 of x plus h cubed minus x cubed over x plus h minus x. Okay? X plus h cubed, we know, so it's the limit as h goes to 0 of x cubed plus 3x squared h plus 3x8 squared minus, plus x h cubed minus x cubed all over, and let's just simplify this, h. Well, x cubed goes out with x cubed. What's going on here? So I can cancel out the h's, so I have 3x squared plus 3xh. The limit as h goes to 0. What happens as h goes to 0? This gets knocked out. Answer, 3x squared. Once again, we started at x to the third and went down to 3x squared. Now, some of you are saying, and so, yeah, so that's the idea of finding the derivative. How do we find the slope of the tangent line? So it makes sense here. So at 0, so for example, if you have x equals 0, what's the slope of that line? 3 times 0 squared, which is 0. And you can see everything's going to be positive because everything is going to be squared times 3. So every single one of these slopes, except for the at x equals 0, has a positive slope. Now, some of you have seen the formula. Obviously the exercises for tonight, you're going to have to do the long way because IB might ask it and I want you to have to practice. So this is 16b. Now some of you have already seen, if you have a polynomial x to the n, how do we find the derivative? This is the notation for derivative. And we know, you might have seen from the formula, it's n x to the n minus 1, right? So x cubed, bring the 3 down, 3 minus 1 is 2. What was it with x squared, right? If f of x was x squared, bring the 2 down, and that was 2x. And then, yeah, so, but this is, we're gonna be using this formula in the class, obviously, but today, how are we gonna prove this? How are we gonna prove this? Okay, well, you'll plug it in the formula. The limit, so the derivative is equal to the limit as x goes to 0 of x plus h to the n minus x to the n over x plus h minus x. Okay, so I ask you, what is x plus h to the n power? So I need to take a second to think about it. I need to pause it and think about it. What is x plus h to the n? Okay, well you remember from binomial expansion, this is n choose 0, x to the n, h to the 0, plus n choose 1, x to the n minus 1, h to the first, plus n choose 2, x minus 2, h squared, all the way down to, sorry, what do we have? N choose n, x to the 0, h to the n, correct? And then what is it's a minus x to the n. Let me just see if it ends up in the camera. Did I get all of that? Yes, perfect. This whole thing divided by, let's just simplify h, right? Okay, what's going on here? What's going on? Well, first of all, this n to the 0, n choose 0, h is 0, and this goes out with this, right? What else? Well, if you notice here, I have n choose 1, which is n, x to the n minus 1. This h goes out with this h, right? Plus n choose 2, and x to the n minus 2, h squared over h, well that leaves me with an h. And all of these terms still have an h in there. This last one is what? Well, n choose n is 1, x to the 0 is 1, and we have x to the n minus 1. Well, what was my intention? To take the limit as h goes to 0. What does that? These go out. What does that leave me with? I'm sorry. N x to the n minus 1. So, in the next class, we're going to go over this, and these are just going to be quick, but today, you don't know this. You're doing these exercises. 16B. Have fun.